Hello, today we will talk about Odmg, that is Object Data Management Group. As we know, this commercial relational DBMS became very successful and because of the SQL standard. But for when we talk about these ODBs, it doesn't have this kind of a standard, and that made it very popular. And after some time, the consortium of ODB, and that is known as this Odmg, Object Data Management Group, they proposed a standard for this ODBs. Okay, so today's focus is Odmg. So outline is object model of Odmg. Then we'll talk about Odmg objects literals, then interface, class, then a simplified version of the object model. Then we will talk about collection types and built-in interfaces for this collection objects. So object data management group, as I told you, it is a consortium of ODB vendors and users. It is object data management group, and they proposed a standard that is known as Odmg 93 or Odmg 1.0 standard. Okay, then this was revised into Odmg 2.0 and later to Odmg 3.0. Now this is the latest one, and the standard is made up of several parts, including the object model. The standard has object model, then it has an object definition language, then object query language, and it also has the bindings to object-oriented programming languages. What is the object model of Odmg? And the Odmg object model is a data model upon which the object definition language, that is ODL, and object query language, that is OQL, are based. And it is meant to provide a standard data model for object databases, just like we have SQL for relational databases. Okay. It also provides a standard terminology in a field where the same terms were sometimes used to describe different concepts. That is the concept of object-oriented databases. And many of the concepts in Odmg model we have already seen them. And object has, when we talk about the objects of this Odmg model, the objects are and literals are the basic building blocks of the object model. The main difference between them is that an object has both an object identifier and a state. A state means its current value, whereas a literal has a value that is known as state, but it doesn't have object identifiers. Okay. And in either case, the value can have a complex structure. The value can have a complex structure, and the object state can change over time by modifying the object value. Object state can change over time by modifying the object value. And a literal is basically a constant value, possibly having a complex structure, but it does not change. That is a literal. And an object has mainly 5 aspects, characteristics, that is identifier, name, then lifetime, structure, and creation. And the identifier, that is the object identifier, is a unique system-wide identifier, or it is known as object ID. And every object must have an object identifier. And it will also have some name, that is some objects may optionally be given a unique name within a particular ODMS. And this name can be used to locate the object, and the system should return the object given that name. Not all individual objects will have unique names. Typically, a few objects, mainly those that hold collections of objects of a particular object class or type, such as extents, will have a name. And these names are used as entry point database. That is, by locating these objects by their unique name, the user can then locate other objects that are referenced from these objects. Okay, so these are that's why these are known as entry points. And it is also possible to give more than one name to an object. All names within a particular ODB must be unique. That is the characteristic. Then we have lifetime also. The lifetime of an object specifies whether it is a persistent object, that is a database object, or a transient object, that is an object in an executing program that appears after the that disappears after the program terminates. And lifetimes are independent of classes or types. That is, some objects of a particular class may be transient, whereas others may be persistent. Okay, that is known as lifetime of an object. And we have structure also. The structure of an object specifies how the object is constructed by using the type constructors. So the structure says how the object is constructed by using the type constructors. The structure specifies whether an object is atomic or not. Okay. An atomic object means a single object that follows a user-defined type, such as employee or department. These are atomic objects. If an object is not atomic, then it will be composed of other objects. For example, a collection object is not an atomic object, since its state will be a collection of other objects. That is collection objects, non-atomic collection objects. And the last characteristic is object creation, that refers to the manner in which an object can be created. And this is typically accomplished via the operation new. The operation new is used for object creation, and new for a special object factory interface. And a literal is a value that does not have an object identifier. The value may have a simple or complex structure. And as we know, there are three types of literals, that is atomic, then structured, and collection. Three types of literals. And an atomic literal means that corresponds to the values of basic data types and are predefined. Okay, these are values of basic data types and are predefined. The basic data types of the object model include long, short, unsigned integers, boolean. All these are predefined data types, and these are specified by using the keywords like long, short, unsigned long, unsigned short. All these are names for this, or the keywords for these types. And we have regular and double precision floating point numbers, float and double, or boolean values, that is known as boolean, or single characters, that is char, and enumeration types like enum. Okay. And we have structured literals that correspond to the values that are constructed using the tuple constructor. Here we have values that are constructed by the type constructors, example date, timestamp, all these are examples. And the built-in structured literals include date, interval, time, and timestamp. Additional user-defined structured literals can be defined as needed by each application. User-defined structures are created using the struct keyword in ODL, as in C and C++ programming languages. And we have collection literals also. They specify a literal value, that is a collection of objects or values, but the collection itself does not have an object identifier. The collections in the object model can be defined by the type generators set, then T or bag T, list T, that is set, bag, list and array. Or we can have another collection type is a dictionary, where we have two attributes, dictionary K comma V, which is a collection of associations K comma V, where K is a key associated with a value V. And this can be used to create an index on a collection of values V. The notation of Odmg uses three concepts for this Odmg, and they are interface, literal and class. And following the Odmg terminology, we use the word behavior. We have behavior to refer to operations, and we have state to refer to properties. Properties means their attributes and relationships. An interface, what is an interface? It specifies only behavior of an object type and is typically non-instantiable. That is, no objects are created corresponding to an interface. Okay, this interface specifies only behavior of an object type and is non-instantiable, which means no objects are created corresponding to an interface. An interface may have state properties, that is, it will have attributes and relationships as part of its specifications. This cannot be inherited from the interface. Okay, hence an interface serves to define operations that can be inherited by other interfaces as well as by classes that define the user-defined objects for a particular application. And a class specifies both state, that is attributes, and behavior, that is operations of an object type, and is instantiable. Hence, database and application objects are typically created based on the user-defined class declarations that form a database schema. And finally, we have a literal declaration that specifies state but no behavior. Thus, a literal sense holds a simple or complex structured value but has neither an object identifier nor encapsulated operations. It has only state, no behaviors. And a class specifies both attributes and behavior, and it is instantiable. And database and application objects are typically created based on the user and class declarations that form a database schema. And we have literal. Literal declaration specifies state but no behavior. A literal instance holds a simple or complex structured value but has neither an object identifier nor encapsulated operations. This is a simplified version of the object model. And in the object model, all inherit the basic interface operations of this object. These include the operations such as we have copy that creates a new copy of object, and delete deletes the object, and same as that conveys the object identity to another object. And operations are applied to objects using a dot notation. Okay, so we have operations are applied to objects using the dot notation. Given an object O, to compare it with another object, for example P, we write O dot same as of P. Okay, the result returned by this operation is Boolean and would be true if the identity of P is the same as that of O, and false otherwise. Okay, it checks whether they are identity of P is same as that of O, and it will return false otherwise. To create a copy of P of object O, we write P is equal to O dot copy. Okay, that is to create a copy we have P, that is O dot copy. So this Odmg inheritance. So in the Odmg object model, we have two types of inheritance relations, and one is behavior only inheritance and state plus behavior inheritance. Behavior inheritance is also known as ISA or interface inheritance and is specified by the colon. That is the notation colon. Hence, in the Odmg object model, behavior inheritance requires the supertype to be an interface. Supertype should be an interface, whereas the subtype could be either a class or another interface. And the other inheritance relationship, that is called extends inheritance, that is state plus behavior inheritance, and is specified by the keyword extends, EXTENDS. It is used to inherit both state and behavior strictly among classes, as both the supertype and subtype must be classes. Multiple inheritance via extends is not permitted. However, multiple inheritance is allowed for behavior inheritance via this colon notation. Hence, an interface may inherit behavior from several other interfaces. A class may also inherit behavior from several interfaces via this colon notation, in addition to inheriting behavior and state from at most one other class via extends. So here we have date object with these are the attributes. Boolean is, that is one operation, behavior. So state plus behavior. And built-in interfaces for collection types. So all interfaces, for example, such as collection, date and time, inherit the basic object interface. In the object model, there is a distinction between collections, where state contains multiple objects or literals, versus atomic objects, where state is an individual object or literal. And collection objects usually inherit the basic collection interface. For example, it inherits like which shows the operations for all the collection types. Given a collection object O, we have a collection object O, and based on that we can define this operations like O dot cardinality operation that returns the number of elements in the collection, and the operation O dot is empty that returns true if the collection O is empty and returns false otherwise. The operations O dot insert underscore element of E and O dot remove underscore element of E. This insert or remove an element E from the collection O. And we have the operation O dot contains underscore element, and you can supply the element, for example E, that returns true if the collection O includes the element E and returns false otherwise. And we have the operation O dot create underscore iterator that creates an iterator object I for the collection object O, which can iterate over each element in the collection. So that is known as create underscore iterator. So these are built-in interfaces for the collection objects. This is how they are defined: interface set, and we have collection set, create union, inset, other set, and we have boolean is underscore subset underscore of. These are operations in set, other set. As we have already seen, collection objects are further specified into set, list, bag, array, and dictionary, which inherit the operations of the collection interface. Okay, so a set type generator can be used to create objects such as the value of object O is a set whose elements are of type T. Then it is set T. The set interface includes the additional operation like P is equal to O dot create union. For example, union of S, and which returns a new object P of type set T again, that is a union of two sets O and S. S will be supplied as a parameter here, and similar operations are there. They create difference of S or create intersection of S. All this operations for set comparison include O dot is a subset of S operation, which returns true if the set object O is a subset of some other set object S, and returns false otherwise. Similar operations, for example, is proper subset of S or is superset of S. So this is the inheritance hierarchy for this collection object inheritance. So we have object and iterator, collection, date, time, interval, and timestamp. So these collection objects can further be divided as set, list, bag, array, etc. And for example, the array type generator, array also inherits the collection operations and is similar to list. Specific operations for array objects we can define as O dot, for example, O dot replace element at. So from this array we can replace one element. So for that we need to supply the index from which the element should be replaced, and the new element that should also be supplied. All these are some example operations. And we have dictionary type also. As I told you before, in the case of dictionary type we have a key and a value. Okay, key, and we have all key and values, all this should be unique. And here we have, this is in inheritance hierarchy. Operations are inherited from the super type to the subtype. The collection interfaces described are not directly instantiable, that is, one cannot directly create objects based on these interfaces. And interfaces can be used to generate user-defined collection types of set, bag, list, array, or dictionary for a particular database application. If an attribute or class has a collection type, for example set, then it will inherit the operations of the set interface. Okay. And we have atomic or user-defined objects. So we can see how these object types for atomic objects can be created. These are specified using the keyword class in ODL. Okay. And in the object model, any user-defined object that is not a collection object is called an atomic object. Any user defined object that is not a collection object is an atomic object, and that is defined via the keyword class. For example, we have class employee and extend all employees, key SSN, and employee student, employee string name, then attribute in SSN, attribute short age, relationship date department works for, then there is a operation that is a reassign in string new name. So reassign is an operation. And this is a user defined atomic object type, and that is defined as a class by specifying its operations and properties. The properties define the state of the object and are further distinguished into attributes and relationships. The properties can be attributes and relationships. So we'll think of this employee class or department class. We can define, for example, in the case of employee, we can create multiple employee objects, and such employee objects will be structured objects, because this employee object will have a complex structure with many attributes, relationships and operations, but it is still considered atomic because it is not a collection. Okay, it is all the details about an employee, it's not a collection, so it is known as an atomic object. An attribute is a property that describes some aspect of an object. Attributes have values which are typically literals having a simple or complex structure that are stored within the object. However, the attribute values can also be object IDs of other objects. Then attribute values can even be specified via methods that are used to calculate the attribute value. Example is the attributes for employee are name, SSN, birth date, sex, age, and those for department. We have seen department also. They are D name, D number, manager, locations, and projects. The manager and projects attributes of department have complex structure and are defined via struct. Okay, so projects and department manager, that again has a complex structure, so that is defined using struct, which corresponds to the tuple constructor of that we have already seen, the tuple constructor. And we can also have a relationship, that is a property that specifies that two objects in the database are related. And in the object model of Odmg, only binary relationships are explicitly represented. And each binary relationship is represented by a pair of inverse references specified via the keyword relationship. One relationship exists that relates each employee to the department in which he or she works. That is the works for relationship of employee. In the inverse direction, each department is related to the set of employees that work in the department. That is the has employees relationship of department. That is the inverse relationship. The keyword inverse specifies that these two properties define a single conceptual relationship in inverse directions. Okay, so the keyword inverse specifies that these two properties define single conceptual relationship in inverse directions. Okay. And in addition to these attributes and relationships, the designer can include operations in object type or class specifications. So each object type can have a number of operation signatures which specify the operation name, its argument types, and its return values if applicable. Okay. Operation names are unique within each object type, but they can be overloaded by having the same operation name appear in distinct object types. And the operation signature can also specify the names of exceptions that can occur during the operation execution. And the implementation of the operation will include the code to raise these exceptions. Okay, so all this must be part of this. And we have class extends. So in the Odmg object model, the database designer can declare an extent, extent, that is a keyword used for declaring extent for any object type that is defined via the class declaration. And the extent is given a name, and this will contain all persistent objects of that class. Hence, the extent behaves as a set object that holds all persistent objects of the class. Extent means that contains all persistent objects of the class. For example, for the employee and department classes have extents called all employees. And for example, for department, we have all departments. And this is similar to creating two objects, one of type set employee and the second one of type set department, and making them persistent by naming them all employees and all departments. Okay, so we have set employee and we are making them persistent by naming them all employees. Extents are also used to automatically enforce the set or subset relationship between the extents of a supertype and its subtype. If two classes A and B have extents all underscore A and all underscore B, and class B is a subtype of class A, that is class B extends class A, then the collection of objects in all B must be a set of those in all A at any point. And a class with an extent can have one or more keys. It consists of one or more properties. Properties means attributes or relationships whose values are constrained to be unique for each object in the extent. For example, we have employee class has SSN attribute as key. Each employee object in the extent must have a unique SSN value. That's what it says. And department class has two distinct keys, D name and D number, and each department must have a unique D name and a unique D number. For a composite key that is made of several properties, the properties that form the key are contained in parentheses. That is composite key means D number, comma D name. And if a class vehicle with an extent all vehicles has a key made up of a combination of two attributes, state and license number, they would be placed in parentheses, state comma license number, the key declaration. Now the concept of factory object, that is an object that can be used to generate or create individual objects via its operations. Okay, it is an object that is used to generate individual objects via its operations. Some of the interfaces of factory objects that are part of the ODM model, you can see some examples. The interface object factory, that is an example for this factory object. Interface object factory. This has a single operation new, which returns a new object with an object identifier. Okay, it returns new objects with an object identifier. By inheriting this interface, users can create their own factory interfaces for each user-defined atomic object type. And the programmer can implement the operation new differently for each type of object. It shows an object factory interface and new interface set factory of this object factory, and it has list factory, array factory, and dictionary factory. All these are from this object factory. And this means that this factory object basically provides the constructor operations for new objects. And as we saw, ODMG supports two concepts for specifying objects types, that is interface and class. There are similarities and differences between interfaces and classes. Both have behaviors and the state, that is attributes and relationships. Then ODMG interface is a specification of the abstract behavior of an object type. The state properties of an interface, that is its attributes and relationships, cannot be inherited from. And then objects cannot be instantiated from an interface. And when we talk about this ODMG class, a class is a specification of abstract behavior and state of an object type. A class is instantiable and it supports extends inheritance to allow both state and behavior inheritance among classes. Then supports multiple inheritance via extends is not allowed. Okay, so that is all about this ODMG. Thank you.